Okay, so this is where the calculator work gets a little fun because your eyes may have already gone there, but this is the formula that we're going to talk about for annuities. But let's start by just talking about what the heck an annuity is. So in the last example, Professor Smart, they deposited, where is it? They threw down $9,000 when their baby was born so that their kid could go to college and they could help pay for it. Unfortunately, some people, when they have babies, don't have $9,000 to deposit. In fact, having a baby is expensive, so I've heard. So sometimes you don't have a lump sum that you want to deposit. So what people do is they deposit a smaller amount every month. Okay, and this is a lot of times what's done for like 401ks or IRAs and stuff like that. They're called savings annuities. And then eventually, with a lot of these situations, we'll also do regular withdrawals after a specific date, such as retirement. So that's what we're talking about when we talk about annuities, regular payments into an investment account. So we got a more technical definition if you want to read the technical definition, but that's essentially what we're talking about. We have a formula, and these letters almost all mean the same thing. P sub n is still the balance after n years. R, still the interest rate. K, still how many times in a year it compounds. The only thing new here is D. And D is just your monthly deposits or your annual deposits. It depends on the phrasing. But the important thing is it's a regular deposit and you know what your time frame is. A lot of times in the homework, we'll be talking about monthly deposits. Okay. So, and sometimes, looking at this note down here, sometimes we don't specifically state the compounding frequency, so we'll just assume it's the same as the deposits. So if we're making monthly payments, we're going to assume monthly compounding on the interest. Okay, so K equals 12 in that example because there are 12 months in a year. So we're going to use this formula. We're going to be typing it all into Desmos, and hopefully it will not be super painful. There are also online calculators that you can use, and you can just input your variables. I'm okay with you using those as long as you are getting the right answer and know how to use them. Because the goal of this chapter is not me saying you need to know how to use your calculator on complicated formulas. The goal is that you know how to find the answers regarding things like annuities and loans. Okay, and sometimes that's an online calculator. Sometimes that's typing it in yourself. And it's kind of up to you. But we'll be using the calculator in here because I'm a math guy. So 6.7. Nope, that's not true. 7.6. A more conservative investment account pays only 3% interest. If $5 is deposited each day into this account, how much is going to be in the account after 10 years? There's two questions because it's also asking how much interest is earned. So let's look at this giant formula. Let's write it down. Let's fill in the blanks. And then let's use a calculator. So again, I highly recommend that when you're starting a problem, you start by just copying down the formula you need to use. P sub n is equal to D times 1 plus R over K to the NK minus 1, all divided by R over N. Nope, all divided by R over K. Look at what we wrote down. Look at what's on our formula sheet. Make sure they're the same. And now we need to start filling in the blanks. We want to know how much is in the account after 10 years. That's going to be our P sub n or P sub 10 because n is 10 years. But we have a bit of a problem here. Okay? We have a bit of a problem because n has to be in the same unit of time as everything else. 10 years is not the same unit of time here. $5 every day. So we're going to want to convert this. Oh, I don't like this problem because we're going to have to convert these things to the same units. So we also have interest, which is, again, according to this note, if the compounding frequency is not explicitly stated, assume that it matches the deposits. And we have 365 deposits in a year. But over 10 years, there's going to be 2 or 3 leap days. So anyway, we're just going to make the assumptions that the book is telling us to make, and we're just going to use 365. Okay, so yeah, every day depositing $5. So N actually is no longer 10. N is how many days? Well, it's 10 years, and each year we're going to say is 365. And yes, I realize we're not thinking about leap years. So N is actually 3,650 here. We're not actually looking for P sub 10. We're looking for P sub 365, 0. I kind of explained that in a bit of a confusing way. You can just write P sub N if you'd like. You can write P sub N. You can write this. I'm okay with either one. Here's the important part. D. What is D? That's a new one. It's the regular deposit each time period. So every time period, we're depositing $5. So D is 5. Keep filling in the blanks. R is our interest rate, 3% interest. As a decimal, that's 0.03. K, how many times a year? We're doing it every day. So 365 times a year. Oh no. I really did muck it up. It was supposed to be 10. I apologize for going back and forth on this. I apologize. We're multiplying it up here. The multiplication I did is N times K. So it's 10 years times how many times in a year. This is where that 3650 comes from. 10 times 365. My apologies. Minus 1. We'll do another one of these problems on the in this video, and we'll do another one on top of that in the examples section of this module, okay? So I can hopefully clarify this with some future examples. And divide all of this by R, which is still 0.03, divided by K, which is still 365. And this is what needs to get typed into the calculator. This is where using something like Desmos makes it a lot easier than doing it by hand. So let's get typing. Let's see what it has to look like. So go over to Desmos, erase that, and let's just try to type it in exactly like it looks. 5 parenthesis parenthesis 1 plus 0.03 forward slash 365. Remember to get out of the denominator. We're stuck in the denominator right now. To get out of the denominator, press tab. Now we need the parenthesis here. We need an exponent. In this exponent, we have two things, so we're going to use a parenthesis. 10 asterisk 365 in the parenthesis. Tab out to get out of the exponent. Press tab to get out of the exponent. Minus 1 parenthesis. So that is our numerator right now in our formula. We have to divide by R over K. So forward slash parenthesis R forward slash K. Tab out of the denominator. Get that parenthesis in. And before we write down our answer, let's make sure that this looks exactly like what we typed and wrote down. And maybe like our cat's paw. 5 times 1 plus 0.03 over 365. So there's parentheses in the exponent now, which is a little new. But those parentheses are fine. Good, we still have that. Minus 1, yep. Divided by that. Yep, divided by that. We've typed it in correctly. That's great. Hi, October. And so this must be our answer. We go over to the answer box in Desmos, check it out, and copy it, rounding to the nearest cent. It's going to be 21,282.07. Whoa! $5 a day did not seem very much. But we're doing it every day. Every day we're depositing $5. That builds up. And we have interest over 10 years. So after 10 years, this much money is going to be in our account. But wait, there's more. There's like a part B. How much interest is earned? So we know how much money we have total, but a lot of that money was from our $5 a day. So how much interest was total? Well, that's a harder question. So how much interest is what we want to know. An intermediate step, how much did we put in? I'm doing $5 a day. $5 a day for 10 years. How much am I putting in? Well, $5 a day, 365 days in a year. We're ignoring leap years right now. And how many years? 10 years. This is how much we've put in. Type that into a calculator. And you get 5 times 365 times 10 is 18,250. So originally, I think, man, we only were spending $5 a day in this investment and we have 21 grand. Well, 18 grand of it was ours. So we're still it's still really expensive, right? We're not just making tons of money for free. We are actually investing a lot of our own money right here. But anyway, the real question is, how much is interest? Well, interest is going to be the total amount, 21,282.07. That total amount minus our contributions. This is the interest right here. Okay, so you type that in. And you're going to say, okay, we still made $3,032.07. Not bad. Nothing to complain about. Doing $5 a day for 10 years. We still got 3 grand of interest, I guess. I guess that's something. But again, 3% interest rate is garbage because of inflation. Anyway, I'm really stuck on inflation, guys. I think inflation... Nope, I'm not going to do it. I'm not going to do it. No inflation video today. Let's do one more example to really drive this home. And I got some positive news, something fun to show you. You'll be happy to see this, I promise. And not the typical math professor, oh yeah, you'll love this. No, you'll actually be happy to see this. So next example is Mr. DJ needs $3,000 in 2 years to purchase a fancy new stereo system. How much should Mr. DJ deposit each quarter with that interest rate in order to have that amount in 2 years? Okay, so here's the good news, and it's not as strong as I wanted it to be. If we type something in Desmos, it's already formatted. If I want to change my previous answer to say, we're going to have 21 grand with a 3% interest rate. If I just want to find what would it be like with a 5% interest rate, now it's 23.5 grand. I don't have to type it in all over again. If I want to know what it's like after 20 years, whoa, 50K now, you just edit a number. So once you type this in for one problem, you've actually typed it in for all of your homework problems that use the annuities formula. Okay? But I misled you a little bit because this next problem uses a slightly different calculation. Because again, just like the previous video, now we're flipping it on its head. Now we're asking what our monthly payment, our quarterly payment should be, right? How much does he deposit each quarter? This is the D value that we're looking for. So now we're looking for the D value, and we know the amount after 2 years. So it's going to be the same formula. We're going to write that formula down again. The amount after 2 years is going to be D times 1 plus R over K to the NK minus 1 all over R over N. I usually use N, but we're using K in this class. That's why I keep saying N right here. And this time we know that we want $3,000. We want $3,000. We don't know the interest rate, so that's still going to be a D. Or we don't know the monthly payments. We do know the interest rate. The interest rate is R. We were told that we have 8% interest. Compounded quarterly. Quarterly means the year is split into quarters. There are 4 quarters in a year. So our K value is 4. It's 2 years, so N is 2. K value is still 4. And we're just filling in the blanks. And then again, algebra is going to come back. We have to solve for D. This is not, it's kind of a messy calculation. It's probably a little easier if we use a calculator first to find this other number and then just divide that number over. Okay? So let's simplify the right-hand side of this equation before we solve for D. This is D times something divided by something. So let's figure out what that numerator is. Let's go to a calculator. We're going to leave this annuities formula up for now. We're going to say, what is, delete that, please. We're going to say, what is 1 plus 0.08 divided by 4, tab out, raised to the 2 times 4, tab out, minus 1. This should be everything in the numerator next to the D. Everything to the right of my finger is what we're trying to type here. And that's going to be 0.17. Give us a ton of decimal places. We don't like rounding error in this class. Let's just write out a bunch of them. And then let's find our denominator as well. Our denominator is 0.08 divided by 4. That's much easier. That's 0.02. We have to solve for D. What we're going to do is we're going to multiply by the reciprocal. Right? Just like if I had a problem that said 2/3 x equals 5, to get x by itself, we'd multiply by the reciprocal, 3 over 2, on each side, because now the 2 cancels, the 3 cancels, and all that's left is an x equals our answer. We have messier numbers here, but it's the same idea. So multiply this side by 0.02. Divided by 0.171659338, blah, 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 tons of digits. But what we do to the right-hand side of the equation, we also have to do to the left-hand side of the equation. And so we have written it like this as well. Those cancel, one on the top, one on the bottom. Those cancel. The right-hand side is just our D. Type this into a calculator and we'll get our answer. Of our monthly payments should be 0.02 divided by 0.17165938. Tab out to get out of there. Asterisk 3,000. Our monthly payments are $349.53. Our quarterly payments. Sorry, this is every quarter. So, if we want $3,000, We want $3,000 after 2 years at 8% interest rate. We're going to have to be putting in $350 every season, every 3 months, 4 times a year for those 2 years. Okay, so the calculator part and this algebra part are really the trickiest things of this chapter, but hang in there and let me know if you have questions. Good luck.